Let us solve a question on expansion path equation. The question is, suppose omega and gamma denote the rewards to labor and capital if the production function is homogeneous such that output is equal to, which is Q is equal to AL to the power alpha times K to the power beta, then every point on the long run expansion path satisfies the following condition. We have to find out the correct equation for the expansion path in the long run. Okay, so what we have been given? We have been given the production function, that is output Q is equal to A denotes the total factor productivity, okay, and L denotes the units of labor employed, alpha denotes the output elasticity of labor, how much our output changes when there is incremental change in the labor, and K denotes the units of capital employed, and beta denotes the output elasticity of capital. Okay, this is our production function, a standard Cobb Douglas production function. Also, we are being told that the rewards to the labor are being denoted by gamma, okay, and the rewards to the labor are being denoted by omega, and the rewards to the capital are being denoted by the gamma. Okay, these denote actually the price of labor and capital here. Okay, now we know that in the long run the expansion path requires. By the way, what is meant by expansion path? Expansion path is simply a path connecting the optimal input combinations as the scale of production increases. That means if I draw the graph here, simple graph, let us say we have units of labor on the horizontal axis and units of capital on the vertical axis. Okay, let us say we have an isocost line and we have the isocont line. Okay, so this is the optimal combination here. Now when the scale increases, let us say we have another isocost line and another isocont line. Okay, so here our optimal input combinations will lie where the isocost and isocont line have the same slope, and when the scale increases, here the tangency between isocost and isocont will give us the optimal input combinations. When we join these points, okay, optimal input combinations, this gives us the expansion path. Okay, so for that what we need to do, we need to find out the what we call the tangency condition here, obviously. So at optimal, first order condition for optimization requires that we equate the marginal rate of technical substitution between labor and capital. Okay, it should be equal to the input price ratios. And what are the input price ratios? Here that is the price of labor upon price of capital. I have told you price of labor, that is the reward to the labor, is being denoted by omega, and price of capital is the reward to the capital, that is being denoted by gamma. So it should be equal to omega upon gamma. Now marginal rate of technical substitution simply means the ratio of the marginal product of labor upon the marginal product of capital. It should be equal to gamma upon omega, which gives us, so MPL, as we know, it is simply marginal product of labor is simply the change in the output due to the change in the units of labor employed. Similarly, marginal product of capital is the change in the output due to the change in the units of capital employed. That is the partial derivative of the given production function with respect to labor and capital, and it should be equal to omega upon gamma. Now partially differentiating this function with respect to L, so the coefficient of, the exponent of L becomes coefficient. So we have alpha A L to the power alpha minus 1, K to the power beta will remain same because we are taking the partials with respect to L. Similarly, the partial derivative of this function with respect to K means the exponent of K becomes coefficient by power function rule. A remains same, L raised power alpha remains same, and the exponent of the K will be subtracted by 1. It should be equal to omega upon gamma. Now here doing some calculation, A and A gets cancelled, which implies we are left with alpha upon beta. Now if I transpose this k to the power beta to numerator, so we have k to the power beta. Transposing this term, it gets multiplied, but the exponent sign will change. If we have plus beta, it becomes minus beta, and if we have minus 1, it becomes plus 1. Okay, simple basic algebra. Similarly, if I transpose this L to the power alpha minus 1 to the denominator, first we have the denominator L raised power alpha. Transposing this, it gets multiplied, but exponent sign changes. So we have L raised power minus alpha plus 1 should be equal to omega upon gamma. Now, so where will I write it? So let me write it here. So we have to find out the expansion path condition. So we are left with alpha upon beta, alpha upon beta. Here bases are same. We can add the exponents. We have k to the power beta minus beta plus 1, and in the denominator we have the same basis. We can add up the exponents. So we have L raised power alpha minus alpha plus 1 should be equal to omega upon gamma. Okay, beta and beta gets cancelled, alpha gets cancelled. We are left with alpha upon beta, k upon L should be equal to omega upon gamma. So k upon L implies k upon capital labor ratio will be equal to, transposing this term, so let us first write omega upon gamma. If I transpose this, it gets multiplied but reciprocated, it becomes beta upon alpha. Okay, so this is the expansion path condition in the long run given the Cobb Douglas production function. So the correct option should be equal to beta upon alpha, beta upon, let us see if we have beta upon alpha, omega upon gamma. So this is the long run condition to achieve the expansion path. Okay, let me repeat it here, expansion path, and let me write it here what exactly is meant by the expansion path. So actually expansion path is a path, so let's write it here. So expansion path, it is a path connecting optimal input combinations is the scale of production increases. Okay, so since this is the optimal combination here, okay, where the isocost and isocounts are tangent to each other, as the scale of production increases, so here we will have another isocount and another isocount, tangency condition. When we connect to these daughters, we get the expansion path equation. I hope I make myself clear. Thank you.